for a PID controller to perform as expected. Changes in the controller output must lead to changes in the opening of one or more final control elements, which must affect the measured variable for the PID controller. Driving a final control element to either limit disrupts this sequence. This requires integral tracking, not output tracking. If the final control element has been driven fully open, control actions to increase the opening cannot be implemented, but control actions to decrease the opening can be. The opposite is true if the final control element is driven fully closed. For the scrubber duct inlet temperature loop, the controller output is the opening of the fuel gas valve. The maximum allowable opening is fully open. The minimum allowable opening is 30%, which corresponds to the minimum firing rate for the furnace. For the scrubber duct inlet temperature controller, avoiding reset windup entails setting the controller output limits to these values. Properly setting the controller output limits avoids reset windup in most PID loops, but not all. The output of the hot air temperature controller is the difference between the actual fresh air damper opening and the output of the characterization function. What value of the difference corresponds to the fresh air damper fully open? It depends on the output of the characterization function, which depends on the fuel gas valve opening. In such loops, three methods are available for avoiding reset windup, namely external reset, integral tracking, and inhibit increase, inhibit decrease. This video only discusses integral tracking. Configuring integral tracking entails answering two questions that are analogous to those for output tracking. Let's do so for the hot air temperature controller. When must integral tracking be active? When the fresh air damper is driven to either of its limits. What value is used for integral tracking? The controller output that corresponds to the limit to which the fresh air damper has been driven. Subtract the characterization function output from the fresh air damper opening to obtain the analog value for integral tracking. To illustrate integral tracking, let's drive the fresh air damper fully open. First, increase the set point for the scrub duct inlet temperature to 85 degrees Celsius. This increases the opening for both the fuel gas valve and the fresh air damper, but neither is driven fully open. If we continue to increase the scrubber duct inlet temperature, the fuel gas valve will be driven fully open before the fresh air damper is fully open. How can we increase the fresh air damper opening without significantly affecting the fuel gas valve opening? Let's decrease the hot air temperature, which will increase the fresh air relative to fuel gas. Reduce the hot air temperature set point to 190 degrees Celsius. The hot air temperature controller increases the feedback trim until the fresh air damper is driven fully open. The hot air temperature lines out at 196.5 degrees Celsius. The hot air controller is unable to attain its set point. Integral tracking is active in the hot air temperature controller. The mode is indicated as AUT star with a hot air temperature of 196.5 and a set point of 190. The hot air temperature controller would normally be increasing its output. However, the controller output is constant at 17.1%. This value is obtained by the integral tracking calculations for the hot air temperature controller. The input to the fresh air damper valve block is the sum of the characterization function output and the output of the hot air temperature controller. Display the current calculations for the summer. Adding 87.2% and 17.1% gives an opening of 104.3% for the fresh air damper. This exceeds the fully open value of 100%. This is the desired behavior for integral tracking. The hot air temperature is above its set point. So the desire is for the fresh air damper to be driven fully open and remain fully open. The analog value for the integral tracking calculations is the current fresh air damper opening less the output of the characterization function. Subtracting 87.2% from 100% gives 12.8% for the analog value for integral tracking. Why is the controller output 17.1%? For integral tracking, the controller output is the analog value for tracking plus the proportional term of the control equation. The proportional term is the product of the controller gain and the control error. The larger the control error, the greater the difference between the controller output and the analog value for tracking. Increase the hot air temperature set point to 200 degrees Celsius. The transition from the limiting condition is smooth. Whenever any final control element is driven to a limiting condition, the transition back to normal control should be smooth. If not, the likely explanation is that reset windup occurred. If tracking is not properly configured, such a result is inevitable. The next video examines integral tracking for the loops associated with the hot air